Hi, and welcome to this section of the Algebra Word Problem Tutor, where we're going to deal with word problems that involve digits. So in these types of problems in your book, you'll see a lot of things talking about the tens digit and the hundreds digit and so on, and how they're related to each other. And a lot of times they'll ask you to find the number. So they'll say something like the tens digit is 2 more than the ones digit, or whatever, and you'll be given some information, and they'll generally say, well, find the number, okay? So, that can be kind of confusing when you first start to tackle it, but we'll take it step by step through some problems here, and I think it'll be clear. So the first problem that we're going to do today goes like this. The sum of the digits of a 2-digit number is 11, okay? If the tens digit is 3 less than the ones digit, find the number, okay? So the first thing we have to do, just like we have to do with any of these problems, is we're going to understand what it's actually asking us, okay? So we have a 2-digit number, and we're going to be asked to find the number. So there's 2 digits, 1, 2, okay? The sum of the digits in these numbers must be equal to 11, okay? And if the tens digit is 3 less than the ones digit, then we have to find the number. So let's do that. Okay, first thing we're going to do, since we're talking about this, I'm going to talk a little bit about tens digit and ones digit. So if we have the number 24, okay, we'll tell you something that you probably already know, okay? This digit is going to be called the ones digit, okay? And this digit is called the tens digit. And if I had a number in front, like 324, that would be the hundreds digit, and so on and so forth. This is stuff you already know, okay? In this problem, okay, we don't know what the number is, okay? But we know it's a 2-digit number, and we're trying to find what these digits are, so we're going to say the digit's going to look like xy, okay? Now, this is not x times y. That's not what I'm trying to say here. All I'm trying to say is we have a 2-digit number, okay? And this is the tens digit, which is x, and this is the ones digit, which is y. These are not multiplied together. This would be like 24 or 32 or 47 or something like this, but the digit here is going to be x and the digit here is going to be y. That's all I'm trying to say there, okay? So given that my number is going to have a digit and another digit, let's go back to our problem. The sum of the 2 digits must be equal to 11. So that must be that x plus y is equal to 11. Okay, that's one part of the problem here, okay? Now let's move on into the next part of the problem. If the tens digit, which is this one, okay, is 3 less than the ones digit, okay, that's the next part. So the tens digit, which is x, is 3 less than the ones digit, okay? So that's the other part of the equation here. So now I have 2 equations and 2 unknowns, and I can solve them. And let's go back and just trace our steps here. We said there's a 2-digit number with a digit here and another digit following, okay? And the problem says that the sum of these 2 digits must be equal to 11. We've got that marked. And it says that the tens digit, which is this one, is 3 less than the ones digit. Okay, so here's our equation, so let's solve. So let's plug in x in here, and we'll go about our business. We'll plug this in, we'll say y minus 3, we're just plugging into here, plus y is equal to 11. We just plugged it into that equation there, okay? Y plus y gives you 2y, okay? We'll just keep our minus 3 is equal to 11, okay? Now let's move the 3 over. 2y is equal to, we'll just add 3. 3 plus 3 is 0. So on the other side, 11 plus 3 gives you 14, okay? We just added 3 to both sides. And then finally, y is going to be equal 14 divided by 2, which is 7. Okay, all we did was divide both sides of this equation by 2. Okay, so that's one part of the answer. Let's go ahead and find the other part. Okay, we know what y is equal to, so let's plug it back in this equation. X is equal to y minus 3. Let's go ahead and plug in what we found for y, which is 7 minus 3. So x will equal 7 minus 3, which is 4. Okay, so now that we know that x is 4, and y is 7, let's construct our big number, because that's what we were asked to do. That would be 47. So the actual answer is 47. Okay? Now let's check and see if this is right, because we can always check. Okay? The sum of the digits of a 2-digit number must be equal to 11. 4 plus 7 gives you 11. Check. Okay? One digit, the ones digit, I'm sorry, the tens digit, which is this one, must be 3 less than the ones digit. Okay, so this is the ones digit, 3 minus that, 7 minus 3 gives you 4. So the tens digit is 3 less than the ones digit. So this number satisfies both constraints, and that's why it is. That's why it's the answer to the problem. So this type of situation with the digit problems, where you're given 3-digit number, a 2-digit number, and some relationship, and find the number, it's going to be the same pattern. You're going to have to write down your digits and write down some relations between your digits, solve the problem, and then put your number down on the problem there on the page. So let's go into the next problem. It's a little bit more difficult, but not really too much more difficult. We're going to ease ourselves into it here. Okay, the sum of the digits in a 2-digit number is 12. Okay, if the tens digit is 2 times the ones digit, find the number. Okay, so again, it's the same thing. It's a 2-digit number, so we're going to have x, y. Those are our 2 digits. Okay, so I'm going to put down, just to remind us, 2-digit number. These are not multiplied together. These are our digits. Okay, the sum of the digits in a 2-digit number is 12. So x plus y is 12. Okay, the sum of the digits in a 2-digit number is 12. Check. Okay. And if the tens digit, which is this one, is 2 times the ones digit, that's the next fact here. So the tens digit is 2 times the ones digit. So you see, all we're doing is we're extracting the information out of the problem. Sum of the digits is 12, tens digits 2 times the ones digit. So let's go ahead and solve the system of equations. Plug it in. 2y plus y is 12. We're just plugging this in here into x. 2y plus y is 12. Solve this. 3y is equal to 12. So then y must be equal to 12 divided by 3. So then y must be equal to 12 divided by 3 is 4. Okay, that's one of the 2 digits. Okay, and then going on to solving for x, you just take this and you plug it back into one of your equations. X is equal to 2y, so x is equal to 2 times 4, because we just found out what y was equal to. So x must be equal to 8. Okay, so let's put this together into the form that we decided ahead of time was going to be our digit, which is going to be 84. X and then y. This, we claim, is our answer. Let's go ahead and check and make sure it's the right answer. The sum of 2 digits in a 2-digit number is 12. Well, 8 plus 4 is 12, so that's checked. Okay. If the tens digit is 2 times the ones digit, find the number. Well, this tens digit is 2 times the ones digit, so that's checked. So these 2 things are satisfied, so that is our number. Same pattern. Have some digits, write some information down about it, solve the system of equations, and write down the answer. Okay, now in this problem, the next problem is a little bit more complicated still, but we'll take it one step at a time, and I think you'll get it. The sum of a 2-digit number is 5. If the digits of the number are reversed, okay, the new number is 9 more than the original number. What is the number? Okay, so you'll see several problems of this type when you're reversing the digits. Okay, so first of all, we have a 2-digit number. We know this. The sum of the digits is 5. Okay, we know how to do that. We add the 2 digits together, they must be equal to 5. Now the tricky part is that if these digits of this number are reversed, flipped around, okay, the new number is 9 more than the old number, the original number. So we have to find that original number. So let's just take it one step at a time. X, y, okay, we'll say is a 2-digit number. Okay, we'll say it's a 2-digit number. Okay? All right, so if it's a 2-digit number, and the next part is x plus y is equal to 5, because the sum of the digits in this 2-digit number is equal to 5. So we just add those up, and we're going to equal to 5. Now, here's the tricky part. If this is the original number, okay, then the reversed number is y x, okay, is the reversed digits, okay? Think about that for a second. I mean, it's not too hard. If you have 24, then 42 would be the reverse. That's all we're doing. We reverse them. It doesn't really help us, but that's what we're doing, okay? So what we need to say is that the reverse digits, okay, minus the original number has got to be equal to 9. That's what we're actually doing, okay? Because it says right here, if the digits are reversed, the new number is 9 more than the original number. So this number is 9 more than this number, okay? Now we do not want to write down this, okay? This is a huge mistake, and that's why I'm pointing it out to you. This is very much what you would think to do, because this is the new number, right? And this is the old number, right? So you subtract them, they should equal 9. Well, you see, in the way we're writing it down, it kind of makes sense. But mathematically, it doesn't make sense, because when you multiply these, when you write these things together, it means multiplication. And we all know that we're not multiplying the digits together. We're just writing them down x, y, and yx to remind us the digits in our problem. We're not actually multiplying these digits together. When you have the number 24, that is not 2 times 4, okay? I mean, that's not what this means. It means something different. So we can't just sit here and say xy minus yx is 9, because this is going to imply multiplication here in our digits, and we're not ever trying to multiply the digits together, okay? So I'm going to write down some big looking expression, and you're going to probably say, well, wow, how did he do that? And then I'm going to talk about it, okay? We're going to understand it together. So let's translate the second part, okay? The new number is 9 more than the original number. Okay, so if this is the new number, how would I write it down in terms of its value? Okay, what I would say is I would say this: y times 10, just bear with me for a second, plus x. Okay, this is the value of reversed digits. Now, before you understand that, let me just tell you kind of an aside. The number 24, what does this mean to you? You know that it means 24, but what it really means is 2 times 10, because this is, by the way, the tens digit, okay, plus 4. 2 times 10 is 20, plus 4 is 24. So anytime you have digits, what you're doing, the value, I mean, just think back to second grade, the value of the digit is the tens digit times 10 plus the ones digit. And if you have hundreds, you'll have a hundreds digit times 100, and so on. And each value in the position of the number has a different weight. Okay, this number means more than this one because it's over to the left, and we all know this. We grew up with this. Okay, but when you're translating it into math here, because you're comparing the two numbers, you're going to have to be explicit. So what we've done is all we've said is if this is our reverse digit, y, which is the digit here, times 10 plus the ones digit, is the value here. Now what's the value of the original number? This one. X times 10 plus y. Okay, that's all it is. This digit times 10 plus the ones digit. And we're saying that this is going to be equal to 9. So the value of the reversed minus the value of original has got to be equal to 9. Okay? So we're taking these digit problems and we're busting them out into actual values, okay? And we have to do that in order to subtract them, all right? So now we have two equations, this one, and two unknowns, x and y, okay? So the first thing let's do is just go ahead and simplify this. So these are our two equations. Let's simplify this bottom one. I'm going to go ahead and rewrite, first what we're going to do is we're going to simplify this one here. So it's 10y plus x minus 10x minus y is equal to 9. Now be careful about your signs. 10y plus x minus 10x minus y, you have to distribute this minus 1 in, is equal to 9. And let's simplify this here. X minus 10 is negative 9x, okay? Negative 9x. And then here is plus 9y is equal to 9, okay? 10y minus y gives you 9y. Okay, now we have two equations and two unknowns. This is an important equation. This is an important equation. I mean, really these are the two equations here. You just have to kind of beat this into some form that you can work with it here. I mean, this is just too big here. You want to do one thing at a time. So simplify what you can is all I'm doing here, okay? This equation is exactly the same as this one. There's no difference between the two, okay? So Our other equation, bringing this down here, is x plus y is equal to 5. Okay, now let's go ahead and solve for x here because I'm going to plug it into our other equation. X is going to be equal to 5 minus y. Okay, just subtracting the y from both sides. Now let's take and plug this x into here. Now we're moving into the next phase. Here's an equation and here's an equation, and we're going to plug one into the other. So minus 9 times the value of x, which is 5 minus y. Don't forget to put in parentheses to keep it straight. Minus 9x here, 5 minus y, plus 9y is equal to 9. Okay, and then minus 9, then we're going to go ahead and solve for y here. Minus 9 times 5 is minus 45 plus 9y plus 9y is equal to 9. Okay, so we have minus 45, minus 9 times minus y is positive 9y plus the 9y and so on. Okay, and then what we're going to have here on the left hand side in terms of y is we're going to have 18y, because 9 plus 9 is 18, is equal to, and we're going to take the 45 and subtract it. So we have 9 plus 45. Actually, I said subtract. What I mean to say is we're adding it. We're adding 45 to both sides. 18y on the left. Okay? So 18y is equal to, and 45 plus 9 is 54. Okay? And when you do this division, if you divide both sides here by 18, 18 divided by 18 is 1, and 54 divided by 18, when you put this and do this math, will equal 3. Okay? So finally, after all of that, we find that y is equal to 3. So we know what one of the digits is equal to. Let's go ahead and find the other digit. Okay? And then we'll review and recap everything that we've done. Okay? Y is equal to 3. We just simply use our other equation here to find x. X is equal to 5 minus y. So so x is equal to 5 minus 3. Okay? So x is equal to 2. Okay, so what does this mean? The original number has a digit of 2 and a digit of 3. Okay? So the original number was 23. Okay, whew, that was a lot of stuff just to find a single number there. But let's review the bidding. Before we actually review anything, let's make sure it was right. Let's make sure that this answer is right. The sum of these two digits must be equal to 5. That was what our original problem says, and this is true. 3 plus 2 is 5. Okay? If you reverse these two digits, 32, okay, and subtract off the original, okay, then it should be equal to 9, and let's just see here. Put this here, borrow like this, 7, 8, 9. So that is correct. So when you reverse the digits, you get 32 minus 23 gives you the 9. So it satisfies both conditions. So let's kind of review the bidding here. Two-digit number, okay? A two-digit number. Sum of the two digits is equal to 5. Reverse the digits, and the difference between them, the digit that you reverse must be 9 more than the original. So the real trick here was to actually take your digits and bust it out like this, because that's what you have to do in order to subtract them. You can't do the xy minus yx. It's just not going to work, because that would imply that these are multiplied digits, and they're not. But when you reverse it, what it means value-wise is y times 10 plus x, that's the value of this digit, minus the first one, x times 10 plus y is the value of this digit. Subtract the two, it's got to be equal to 9. That was our second constraint. And then after that, it just becomes a matter of doing the math. So we simplify this equation. Here is all we did. We just multiplied and added together and simplified some more. So we had an equation here and an equation here, and we're going to solve these system of equations. So we do the same thing we always do. We take one of the equations, solve it for x, okay, which is what we found here, plug it back into the other equation, which was this one here, the 5 minus y we put in for x, and then we just simplified and solved for y, take this digit, put it back in and solve for x. And that's just going to be the way you solve every system of equations. You have two equations, you plug one into the other, solve it for that variable, take that answer and plug it back into one of the original equations and solve that one. Okay, now once we've done one of these digit problems that has the reversal, the other ones aren't going to be as hard because you're going to have the idea of what that means, okay? So let's go on into the next one. The ones digit of a two-digit number is 1 more than the tens digit. Okay? If the digits are reversed, the new number is 48 more than 1/2 of the original number. Find the number. Again, they get harder and harder, but these are real life problems that you'll have to solve on your tests. So let's read it one more time. You have a 2-digit number. The ones digit is 1 more than the tens digit. If the digits are reversed, the new number is 48 more than 1/2 of the original number. So we have to just take it one step at a time and write this down mathematically and solve it. Okay, so if the original digit is x times y, actually not x times y, xy. This is the 2-digit number. Okay, then what we're going to have here is, let's go ahead and do the first part. What we're saying here, the first part, the ones digit, which is this one, is 1 more than the tens digit. Okay, so congratulations, we've written the first equation down. The ones digit is 1 more than the tens digit. Okay? If the digits are reversed, and by the way, if they're reversed, it'll look like yx is a reversed number. Okay? If the digits are reversed, the new number is 48 more than 1/2 of the original number. So let's tackle that one. First of all, let's write down what the new number's value would be. Y times 10, because it's the tens digit, plus x. Let's tidy up our stuff here. That's the value of the new number. Okay? Y times 10 plus x. Okay? Is equal to, because it says if the digits are reversed, the new number is 48 more than 1/2 the original number. Well, what would the original number be? Okay, the original number is this one. The value of it would be x times 10 plus y. X, which is the tens digit, times 10 plus the y. This is the value of the old number. Okay, so the new number is 48 more than 1/2 of the original number. So I'm just going to write it down and show you. The new number is 48 more than 1/2 of the original number. Okay? So you see, when you write it down in equation form, it's not so bad. I mean, you just have to kind of translate that English into actual numbers. It's 48 more than 1/2 of the original number. And you have to keep it in parentheses because this entire thing is the original number. So we're really almost done. I mean, we've got the two equations. Okay, because we have x and y. I mean, it's ugly, but we have x and y, and we have x and y here. So let's work on simplifying this ugly-looking equation. So let's go. 10y plus x, that's all we have on the left, is equal to, and I'm going to keep the 1/2 for now out there, 10x plus y plus 48. Okay, so let's simplify a little bit more. 10y plus x is equal to 1/2 times 10 is 5x plus 1/2 times y is 1/2 y plus 48. Okay? So let's go ahead and move x over here. Okay? And we're going to move y over here. Okay? We're going to take this 5x and we're going to move it over here. Okay? So we're going to have x minus 5x is 10y. Let's just write it like this. Plus x minus 5x. All I'm doing is I'm subtracting 5x from both sides. It disappears from the right. I'm not going to touch the right. I'm going to leave it here because I don't want to confuse you on the math of all things. So the math really isn't that hard here. I'm taking the 5x and I'm subtracting it so it disappears from the right. It pops up over on the left. Okay? So 10y is equal to negative 4x. Whoops. That's not what I meant to say. 10y minus 4x is equal to 1/2 y plus 48. Okay? 1/2 y minus 48. And then what I'm going to do over here is I'm going to move the y over here. So I'm going to have negative the 10y over here. Negative 4x is equal to 1/2 y minus 10y plus 48. Okay? Plus the 48. Okay? So let's keep on going. Now I have 1/2 y minus 10y. What I'm going to do here at this point, and I don't usually do this, but it's going to make it easier. I'm just going to do this in decimal form. What is 0.5 minus 10? Well, it's negative 9.5. 9.5y, and we're going to keep our 48, okay? And again, this is our equation. So we're just simplifying this equation. That's all we've been doing this entire time, just to make it easier, okay? Now let's go ahead and solve this equation. Okay, now all we've done is we've taken our big equation and we've simplified it into this form, okay? But in big picture terms, this is an important equation and this is an important equation. So let's solve these two equations. We already have this solved for y, so let's take and put it down here in this equation like this. Let's plug in, okay? Negative 4x is equal to negative 9.5 times y, which is x plus 1, plus 48, okay? Like this. And what we're going to do now is we're just going to solve for x, okay? So negative 4x is equal to negative 9.5x minus 9.5, because negative 9.5 times 1 is negative 9.5, plus 48, okay? Now let's move this over onto this side, this 9.5x, we're going to add it over here. So what we're going to have is negative 4x plus 9.5x is equal to, and on the right hand side we have negative 9.5 plus 48, which is 38.5. Okay? On the left, when you add these two things together, you get 5.5 is equal to 38.5, and then to solve for x, you just divide both sides by 5.5, which will give you 7. Okay, so that's one of the digits, is 7, okay, when you do that. Now we're going to take that and we're just going to plug it over in here. So y is equal to x plus 1, y is equal to, put it in 7 plus 1, y is equal to 8. Okay, so the actual number that we're trying to deal with here is 78. Okay, 78. Let's see if these two things make sense. The ones digit, which is this one, is one more than the tens digit. That makes sense. If the digits are reversed, which is 87, the digits are reversed, the new number is 48 more than 1/2 the original number. And I'll leave it as an exercise to the student that if you take this and you divide it by 2 and add 48 to it, you will get 87. Okay? So this is kind of a complicated looking problem, and there's a lot of math here, but it's also just because I keep every step by step, hopefully so you don't get lost. But here's the relation between the two digits. You have the ones digits, one more than the tens digit, and then this one is just simply saying what that problem spells out. The new number is 48 more than 1/2 of the old, and it just takes some time to multiply this out, which is what we started doing here, simplify it down into something reasonable so that we can plug in the other expression and solve for x, take that, and plug it in and solve for y. Okay, the last problem we're going to do in this section goes like this. In a 3-digit number, so this is our first problem with 3-digit number. The hundreds digit is 1/2 of the tens digit, and the ones digit is 1 more than the tens digit. If the sum of the digits is 11, find the number. Okay? So first thing is we have a 3-digit number. Okay? So it's going to be x, y, z. It's a 3-digit number. Okay? Let's go ahead and start translating this stuff. First of all, we know the sum of the digits is 11. That's given in the problem in the very last sentence. So I always like to start out with x plus y plus z is equal to 11. Okay? Now let's move on up. The hundreds digit, which is this one, is 1/2 of the tens digit. So x is equal to 1/2 y. Okay? The ones digit, which is this one, is 1 more than the tens digit. So z is equal to y plus 1. The ones digit is 1 more than the tens digit. Okay, so I think we have all of our information. We have 3 equations and 3 unknowns. The sum of the digits must be 11. The hundreds digit is 1/2 of the tens, and the ones is 1 more than the tens. Okay, so there's a lot of words, but when you write it down, it doesn't look so bad. This is 3 equations and 3 unknowns, so how will we solve it? Let's take these 2 equations and plug them into the first one. Okay? X is given by this, we'll just plug in 1/2 y plus z will plug in as y plus 1 is equal to 11. All we did was take these 2 and plug them in. Now let's solve for y. Okay? Let's solve for y. So what we'll have here is y plus y is 2y plus 1/2 y. Let's just use decimals here. 2.5y plus 1 is equal to 11. All we did was add the y's up. 2.5y plus 1, this one here, is equal to 11. So then 2.5y is equal to 10. Okay? So now we can solve for y by dividing by 2.5. Okay? So y is going to be equal to 4. That's one of the digits. All we did was we took these two equations, put them in here, and bang through and solve for y. Okay, now how do we go from there? We have an expression for x in terms of y and z in terms of y, so it's just a simple matter to find the other digits. X is 1/2 y, so x is 1/2 of, we'll just plug it in what we found, 4. So x is equal to 2. Okay, and then for z is equal to y plus 1, so z is equal to 4 plus 1 because we found 4 for y, so z is equal to 5. Okay, so it's a 3-digit number x, y, z, which will be 2, 4, 5. That's the digit we're looking for, 245. And let's just make sure that it makes sense. Let's check it. The sum of the digits must be equal to 11. 4 plus 5 is 9, plus 2 more gives you 11, so that's right. And the next thing is, the hundreds digit here is 1/2 of the tens digit, which is right. 2 is 1/2 of 4. And the ones digit, which is this one, is 1 more than the tens digit. 5 is 1 more than 4, so you get the answer there. So in this section, we dealt with digit problems. Those are problems that have a 3-digit or 2-digit number or 4-digit number and some relationship between the digits, and you want to find the number. They're really not that hard. It's just a matter of pulling out the information from it and making sure you get your equations right to begin with, so that as you solve the problem, you won't make any silly mistakes from the beginning. And that's how you tackle digit problems.